Bismillahirrahmanirrahim. Assalamu alaikum. Today I would like to present to you people about the computer science overview, here in which we are going to cover the very basics of the computer. So moving onwards, why we study computer sciences, as we did the job titles of different fields, and what are the possible outcomes, what is actually the future of a computer scientist. So it can work in a different field as a software engineer, as a programmer, working as a developer in the software houses, and the data. It can work for the data and administrative works for the network, the database, communication jobs, network programmer, web developer, web designer, and moreover the information technology scientist, right? So it is one of the very highest professional degree, highest paid professional in the world. When there is a computer programmer, and it can work for the developing the different mobile applications of operating systems, and it can work for the different games, right? So it's one of the very highest paid ones. Fast growing IT jobs, according to the US Department of Statistics in predictions, the IT forces, there is a ratio of about 2000, between 2004 and 14. There was the ratio there was an increase of about 30% increase in a jobs, about 30% increase. New jobs have been introduced and have been observed, and similarly more of the some statistics figures according to the importance and the work of the computer scientist, between the 2000 and 2014, what was the US statement. Similarly, for the software engineer, the number one job, uh, and the job growth ratio is 46% and more, and so on. So here is the overview of there's a chart here, and clear chart, and that's how you can, if it would be clear to you people about it. Mathematical scientist 2%, physical scientist 4%, life of a scientist 4% ratio in the world, and social scientist 9%. But about the engineers are then 22% of the ratio of the world is the of engineers, and the computer specialists are the 59%. So more people are working in this field and are greatly working in this. So right, so both of that about it. So why we have to do that? For the because to develop our to train our mind, to polish our mind, our skills, and when we have a IT background, when we have the basic computer knowledge, basic technology information, and we have an interest on that, we can work, we can accept the IT challenges, we are ready to work to solve that technological problems, and we are ready to accept the challenges that the world is facing today. So the creativity and intellectual challenges, programming extremely challenged, obviously. So to help others when we are interested in doing projects with other, and in like a team member, and doing researches, and either working from home or from working from offices. So it's a lifelong learning process, and ever paid. Why computer science and engineering impact is here, advances in the computer drive, advances in all the fields is here, and what about that multi-factor productivity growth throughout the economy, right? So when we people are accepting the challenges by accepting the programming jobs, or doing the projects online, right, from sitting at the home and doing the computer jobs, right? So we are also improving the economy rate of a country, yes, the economy, like GDP growth rate. Exponential progress is here. So with the passage of time, with the passage of year, as the technology, this was an exponential growth about the technology, about the challenges, that how technology is being advanced as being more productive, more fast, and more efficient. Exponential makes many predictions. Look, here are some quotations, and that here are some well sayings from some of the great people. I think there's a world market for maybe a five computers. That was Thomas J. Watson, the chairman of IBM in 19. So computers in the future may weigh no more than 1.5 ton. It was stated as in 1949. Quite true at that time, and it's today's world, and now today it's much more truth. We are having all that smart systems in our pocket. There is no reason anyone would want a computer in their home. Ken Olsen, founder of the DEC Digital Equipment Corporation in 1977, like that, and 640K ought to be enough for anybody. Bill Gates, so CEO of Microsoft in 1981. And intellectual property. That's all of the motivation quotes, and the statements that are being said by the very great people to make you people motivated, inspiration towards this field, computer science, and will polish you, will groom you, will inspire you, motivate you to continue your work and studies in this. So another, the software industry is going to make more breakthroughs in the next 10 years, and that is made in the last 30 years. So software is going to not really going to transform not just everything about the computer industry, but the way that everything is. Property, how the computer enhanced driving, different applications, different world in today's world, that how people and how different applications regarding to the computer science work are working. A teacher for every learner, harnessing systems are examples. You people about talk about that science and transforming uh, that matter and engineering kind of problems when you are accepting the real life challenges and smoothing it down with the help of the IT technology, and making it more efficient and more faster and more user friendly to the mankind. So the re-architecturing the internet, transforming the entertainment and the art. Here are the different examples and the applications that are helping, that are that help us to accept the challenge. So as I've told you about that arts, and in arts it's helping is as a big business. It is in business in bringing the growth, making our economy strong. It is helping us. So in arts, film reproduction systems, animations, different Unity-based games. When you work on some graphic designing and graphic arts, business. Information technology, process improvements, business infrastructure, modern, all are the examples of that business. So when it's helping us in commercial, as a commercial use, PC engineer in different fields, and the equity theory, so IT, and the software developer in the why computer science and engineering impact is here, advances in the computer drive, advances in all the fields is here. And what about that multi-factor productivity growth throughout the economy, right? So when we people are do accepting the challenges by accepting the programming jobs, or doing the projects online, right from sitting at the home and doing the computer jobs, right? So we are also improving the economy rate of a country, yes, the economy, like GDP growth rate, right? Bring us a great Security, and when people are worried about that biometric systems, like forensics reports identification and the cause of the death and the age progression, and a biometric system for that the computer identified and authorized identification of that identification of a person by as a key passwords and all that. So face recognitions, iris scans, fingerprints, the thumbprint, palm detectors, all are the examples. Network intrusion, malicious attacks, it is providing us that security, working as a security. Media in telecommunications, providing us a call center and voice over IP, telecommunication, file sharing, podcasting, video streaming, call centers, all and more, much more it is helping us all. So what about the basics that computing systems, computer everywhere, every one knows about that, the machine that is being instructed, that is being designed so it can work according to the instructions being given to it, and with the help of software, and actually how you are controlling that hardware with the help of a software, right? So to help, and the objective of that machine is to minimize the human effort, to help human to for computing things or computing different kinds of problems. So hardware like keyboard, mouse, and these things. Software, the programs according to this according to which the computer is going to work for. So how you are trained it will work according to it. So controlling the hardware, it includes the hardware, includes CPU, that is this central processing unit, and including the processor and the ALU. ALU, the responsible for performing arithmetic logic operations. Internal memory includes RAM and ROM. External memory, there is a hard disk and that all that external media memory like flash, so internal organization, how does that look like? That when people give input to the CPU and get an output, but how it will interact with the memory, the input is being given, the system is being instructed, how you are going to perform an operation between the operands, and the ALU would be responsible for performing the arithmetic logic operations, and with the help of that memory the instruction is being fetched, and the word is being fetched from the memory and is being given, the answer is being given also to the memory and be saved here and is also displayed at our monitor with the help of an output devices. So that's how the internal order. Personal computer, different types of computer including the workstation, supercomputers, and the personal computers. So here are the different descriptions of it. Detailed that supercomputers are the fastest computer and being used for the research world. So computer software, how you will define it. There is a hardware and application software, and with the help of an operating system, you are that the interface, operating system is an interface between these two, hardware and application software, and the user is going to interact with the hardware by using the application software through an operating system. So that was a layered approach that people might be clear about the different roles of each layer of each thing in an interface in an overview. Operating system, as I have told you, interface between the user and the hardware, and there contains the different drivers interface and the platform that is being provided to you so that you may use your applications as well. The Windows, Linux, Ubuntu, Solaris, all are the examples of the different operating systems, and actually it's responsible for performing functions such as the printing files and copying files and listing files, and that how you are going to execute that app. So software tools are the word processor, spreadsheets, database, CAD packages, Mathematician, MathCAD, and Apple. All that mathematical computation tools are there. Graphic tools, Paint for so how our computer, how you are going to, sorry, how you are going to execute a basic computer program when there is a program being written in a hardware in a hard language which is known as different languages, like C language is one of that hard code that is being understood by the human. So a programmer is written by a human understandable language. It is going to be compiled and is being compiler used to do its work, being the The high level language is being converted to a low level language, that is actually the machine language, so that it may be understood by the machine. So this is why it's known as the machine language. There is a link and load. Link and loader provide all that different stuff, that how you're attaching the linking it and helping us to execute further, and that's how the program is output. So compiling into the source program and the object program. The high level language program being written is the source program, and the object program and how is a binary code language binary program. So the next is decoding and debugging. So compiling, as I've told you, high level language into machine language conversion. So I've told you about the source program and object program as well. Linking and loading includes the link the other necessary machine language statements to the object program and loading the program into the memory. So that's how uh, being processed and a program is being executed.